Hello, I'm Raseen Shbeeb from Syria, and I'm going to be presenting you my research on the best dielectric materials. Capacitors have many uses, especially in electrical devices, so everyone strives to develop capacitors to make the best use of them by choosing the appropriate and best insulator that provides the required needs. What's a capacitor? A capacitor is an electronic component that stores electric charge. The capacitor is made of two close conductors, usually plates, that are separated by a dielectric material. The plates accumulate electric charge when connected to a power source. One plate accumulates positive charge and the other accumulates negative charge. How does a capacitor work? First, we can note that a metal typically has an equal amount of positively and negatively charged particles, which means it's electrically neutral. If we connect a power source or a battery to the metal plates of the capacitor, a current will try to flow. However, because of the dielectric between the plates, the electrons won't be able to pass through the capacitor, so they will start accumulating on the plate. After a while, the battery will not be able to push electronics to enter the plate because of the repulsion of those electronics, which are already there. How do we determine the value of capacitance? There are two main equations to determine the value of capacity. These are C equals Q over V, where C is the capacitance in farad, Q is the electric charge in coulombs, and V is the voltage between the capacitor's plates in volts. The capacitance C of the plate's capacitor is equal to the permittivity times the plate area A divided by the gap or distance between the plates D. The total energy that can be extracted from a fully charged capacitor is given by the equation U equals 1 half C times V squared. Dielectric materials. Dielectric materials are essentially insulators, which means that no current will flow through the material when a voltage is applied. However, certain changes do happen at the atomic scale. When a voltage is applied across a dielectric object, it becomes polarized. Since atoms are made of positively charged nucleus and negatively charged electrons, polarization is an effect which slightly shifts electrons to the positive voltage. Dielectric constant. The dielectric constant of a material, also called the permittivity of a material, represents the ability of a material to concentrate electrostatic lines of flux. In more practical terms, it represents the ability of a material to store electrical energy in the presence of an electrical field. All materials, including vacuum, store energy when placed in an electric field. The permittivity of vacuum is defined as the physical constant epsilon 0, which is approximately 8.854 times 10 to the minus 12 farads per meter. This constant appears in many electromagnetism formulas. Since most capacitors are not made of vacuum, it makes sense to define permittivity for every material. The permittivity of a material is defined as epsilon equals epsilon r times epsilon 0, where epsilon is the absolute permittivity and epsilon r is the relative permittivity. Epsilon r is a number which is always greater than 1, meaning that all materials store more energy than free space when subjected to an electric field. Different materials have different values of relative permittivity. Here we provide a list of materials commonly used in capacitors along with their epsilon r values at the frequency of 1 kHz at room temperature. We notice that calcium copper titanate has the highest value of epsilon r, which makes it one of the best dielectric materials. Calcium copper titanate properties. Dielectric strength. Unfortunately, there is a limit on the voltage an insulator can withstand before conducting electricity. All materials have an upper voltage limit called breakdown voltage. The breakdown field for calcium copper titanate centering at 1100 degrees Celsius for 4 hours can reach 21 kilovolts per centimeter, which is considered a very good value. Dielectric loss. Calcium copper titanate has a very acceptable value of dielectric loss. This graph shows that as the frequency increases, the dielectric constant decreases. We notice that the dielectric constant value changes when temperature changes. Practical section. I made a plate of insulator in a school lab by mixing calcium hydroxide, titanium oxide, and copper oxide and then heating them to 150 degrees Celsius in the oven and subjecting them to great pressure, but I did not have time to test the material in order to derive the numerical values for how much it is insulating. In conclusion, we learned that with change of the insulating material in the capacitor, its properties change. We also concluded the best insulator for the capacitor, which is calcium copper titanate, and we got acquainted with all its properties. Suggestions and benefit to the community. In my country, Syria, there is a real problem with the electricity, as the electricity is cut off most of the time of the day. People are using commercial batteries for lighting whose average life may be from 6 to 12 months. The capacitor of calcium copper titanate has a very large capacity because of its large dielectric. So we can use it as a battery that charges and discharges, but it will have a much longer life than batteries. So it will help a lot in solving even a small part of the electricity problem in my country. And these are my references. That was it, and thanks for listening.